So I noticed something interesting on one of the multimeters that I have. And so I thought I'd compare three different multimeters for one particular parameter, which is called the input resistance. So most modern meters have a very high input impedance. I think I showed my old, well here, let me just pan up to it. I think I showed you this guy here. And he has an FET input, and so on all ranges he has a 10 megohm input. So that's pretty typical of multimeters, 10 megohm input. But high-end meters tend to do better than that. So this is the specifications for a Keithley 2015. And on the lower ranges, not the 100 volt, 1000 volt range, but the lower ranges, the input impedance is greater than 10 gigohms. Okay, so that's 10,000 megohms. And so it's 1,000 times better than the old meter. Okay, good. So 10 gigohms, that's a pretty high number. So I also have an HP 34001, and its input impedance is, let's see here, its input impedance is, here it is, input resistance, they call it input resistance, selectable, that's really weird, I didn't know that, selectable, 10 megohms or greater than 10 gigohms. So I don't know why you want to select it for 10, but whatever. I didn't know it was selectable until now, and it's actually a menu item. You can actually go change it in the menu to make it 10 megohms on all ranges, fixed, or greater than 10 gigohms on whatever range it wants to pick. Now that's similar to the Keithley. The Keithley is 10 gigohms until you get to the 100 range or the 1000 range, and then it kicks down to 10 megohms. But there is no option to lock it down. But whereas on the HP meter, you can lock all the ranges down to 10 megohms. So that's interesting. And the way that you, quote, select it is to go into the menu. So if you have one of these meters, you go into the menu, and there's one menu item that's input R, and you can change it from 10 megohms to greater than 10 gigohms. So I'll show you that here on the meter. So let me rearrange the camera. All right, so here are the meters. In order to show this effect, you need to change the range to manual, not auto. And I have them both set to 6.5 digit. And here on the HP one, this is the HP 34001, and this is the Keithley 2015. So in order to do that, you go into the menu system, and you go down, and it goes to AC filter. You go over, continuity, over, input R. So you go down, and it's greater than 10 megohms or 10 megohms. Greater than 10 gigohms or 10 megohms. So you can get to choose which one you want. So I'm going to set it to greater than 10 gigohms. Enter. And so now I'm going to measure a 9 volt battery with the HP meter on top. So here goes. Here's the 9 volt battery. Very stable, 6.5 digits. And I'm going to let loose, and it kind of floats around. So let's do it again. And it's sort of staying around, then it, so that 10 gigohms, the whatever you measured is kind of stored on a capacitor somewhere in the meter, and it's just kind of drifting around now. Okay, so that's how that meter reacts. Okay, so let's take a look at the Keithley meter. And the Keithley meter also says greater than 10 gigohms. So let's measure the battery with it. And 9.24254. I didn't compare the two, but anyway, I know they're within a very close tolerance when warmed up. And now I'm going to take it off. And now it also floats around. This one's kind of floating down. Let me go back on the battery. Okay, now let me let loose. And it sort of floats around. All right. And I have no filtering on, and I have slow reading updates just so it won't bounce around. Anyway, so that's what those 2 meters do. Now let me show you a third meter. Do I have a, let's see, do I have a specification for it? Yeah, I do. So let me go back to the piece of paper here just a second. Okay, the other meter that I own is a Fluke 8842. It's only 5.5 digits, but a very nice old meter. And it has ranges and it has input resistances. So for ranges up to 20 volts, it has greater than 10 gigohms, 10,000 megohms. And then on the upper 2 ranges, it's 10 megohms. So it's almost identical to the other 2 meters. But it acts much different. So let me show you that. It's in a different room, so I'll have to take the camera over there. All right, this is a Fluke 8842. It's over in my office, so I had to move the camera. So let me zero the voltmeter here. So again, it's just, this one's just set to auto. Just turn it on, it just does what it does. So I'm going to measure the battery again, 9.2398. And let me release the battery, and it just stays there. So whatever input circuitry is on the Fluke, it's absolutely amazing. It'll hold that voltage for a very long time. The stray capacitance and leakage that the Fluke has is just, it's just phenomenal. I don't know what they did, but they got it right. Look at how stable that thing is. I'm not touching the battery. The probes are just in the air. Let me short the probes out again. And let me now touch the battery. There we go. Okay. And then let me release the battery. 1, 2, 3. And it just stays there. So even though the quote input resistance may be the same on all 3 meters, the stability of this meter is just outstanding. So I kind of believe this one, when it says greater than 10 gigohm input, it's greater than 10 gigohm input. It's really good. So I don't know if there's any other way to make those other 2 meters act more appropriate, but they certainly aren't holding up against this old Fluke.